Hi, in this video we'll do some examples for the second part of the fundamental theorem of calculus. Well, let's recall that fundamental theorem of calculus FTC part 2 says that, well, if f is an antiderivative of continuous function f, then the value of the definite integral of f of x dx from a to b is equal to this notation. Means that evaluate the function at upper limit, evaluate the antiderivative at upper limit of the integral, minus evaluate the antiderivative at the lower limit. So you need to just find antiderivative, and then by evaluating at the limits and subtracting, you get the value of the integral. Let's do these examples. Here the integrand is x squared minus 2x plus 3. So we need to find antiderivative of that. So you see the antiderivative of x squared is x cubed over 3. Antiderivative of 2x is x squared. And antiderivative of 3 is 3x. Or you can put plus c or not. When you're evaluating a definite integral and using second part of fundamental theorem of calculus, that plus c is not important. Is an antiderivative of the integrand. So it means that using fundamental theorem of calculus part 2, we have x cubed over 3 minus x squared plus 3x go from 0 to 1. It means that evaluate that at upper limit minus evaluate, upper limit, sorry, this is not upper limit, 1 squared 3 times 1 minus evaluated at a lower limit, and this gives us 1 over 3 minus 1 plus 3, which is 2 plus 1 over 3 to 7 over 3. How about this one? Well, a cosine of x, we are looking for antiderivative of sine x. So negative cosine of x is an antiderivative of a sine x. So the fundamental theorem of calculus part 2 says that evaluate that at upper limit minus its value at lower limit. So minus cosine of pi over 2 minus negative cosine of pi over 3. So cosine of pi over 2, you have to know this is 0. There is a minus, this will be plus. Cosine of pi over 3, remember pi over 3 has cosine of 1 over 2. So this will be 1 over 2. And the definite integral of e to the power x from 1 to 2, we know that e to the power x is an antiderivative of the integrand, which is e to the power x itself. So this is going to be e to the power x going from 1 to 2, and evaluate at the upper minus evaluate at lower. So this is e squared minus this other one. So we have to find an antiderivative of x cubed plus 2x plus 1. X cubed plus 2x plus 1 over x. If you look at it this way, antiderivative of quotient is not easy to find, but if you separate it, you see that you have x cubed over x plus 2x over x plus 1 over x. And then you simplify basically these guys. Let me just push it a little bit back there. So simplify, you get x squared plus 2 plus 1 over x. So the antiderivative of that function is now sum of antiderivative of each summand. It will be x cubed over 3 plus 2x plus ln. You can put absolute value of x, but here you don't need that because it is integral on positive interval. Is an antiderivative of the integrand. Derivative. So by fundamental theorem of calculus part 2, we have x cubed over 3 plus 2x plus ln x, go from 1 to e, evaluate at upper 1, e cubed over 3 plus 2e plus ln e minus 1 cubed over 3 plus 2 times 1 plus ln of 1. This is e cubed over 3 plus 2e plus ln of e is 1 minus 1 over 3 minus 2, and ln of 1 is 0. So this way we have negative 1 minus 1 over 3, so negative 4 over 3 e cubed over 3 plus 2. So you find that, and then from there evaluating is easy. How about this one? Well, we know that antiderivative of 3x is 3x squared over 2. Antiderivative of 1 is x. This is, you see, there's 2 times 1 over x squared plus 1. X squared plus 1 is antiderivative of tan inverse. And this is 2 tan inverse of x is an antiderivative. Okay, so by fundamental theorem of calculus part 2, we have 3x squared over 2 plus x minus 2 tan inverse of x, go from 0 to 1. 3 times 1 squared over 2 plus 1 minus 2 tan inverse of 1 minus 3 0 squared over 2 plus 0 minus 2 tan inverse of 0. This is 3 over 2 plus 1 minus tan inverse of 1. What is the angle whose tan is 1? That's pi over 4. Minus 0 minus 0 minus plus 2 tan of tan inverse of 0. What is the angle whose tan is 0? That's 0 again. So by that, then we have the whole value is 5 over 2 minus pi over 4. And the last example here, well, x root x and 1 over x cubed, we can write it as x to the power 1 over 2 plus x to the power negative 3. Then the antiderivative is 1 over half plus 1, x to the power half plus 1, plus 1 over negative 3 plus 1, x to the power negative 3 plus 1. So if you simplify that, this will be 2 over 3 x to the power 3 over 2 minus 1 over 2 x to the power negative 2. Well, but let me do a little bit more here. 2 over 3, this is x cubed, root of x cubed, minus 1 over 2x squared. So using fundamental theorem of calculus part 2, then we have 2 over 3, the third root of x cubed minus 1 over 2 to the power x squared, go from 1 to 9, evaluate at upper one minus at lower one, 2/3 root of 1 to the power 3 minus 1/2 to the power 1 squared. So this guy, you see, root of 9 is 3, then you can put to the power 3. This is 27 times 2/3 minus 1/9 squared is 81, so 162 is down there, minus there. 1 to the power 3 is 1, root of 1 is 1, so minus 2/3 plus 1/2. You can simplify this thing yourself and just get the number you're looking for. But the point here was that you can evaluate that and get the number for that using fundamental theorem of calculus.